Hello, everybody. It's Mrs. Pound, and we are starting a new chapter, chapter 36 on magnetism. We just finished out electricity, and we're going to see how the two are related. So, our objectives for today's video are to describe the differences and similarities between electric poles and magnetic charges, and to relate the motion of electrons within a material to the ability of the material to become a magnet. So, let's first talk about the magnetic poles. So magnetic poles. On the magnet, there are two poles. So a magnetic pole is one of the regions on a magnet that produces a magnetic force. So we have the north and the south poles, which sounds a lot like our Earth, right? Because our Earth also has a magnetic field. Now, if the north pole of one magnet is brought near the south pole of another magnet, the poles will attract each other. So the poles are a lot like electrical charges where opposites attract. Okay, so if there was another magnet brought in here, this north end would be attracted to the south end of another magnet. Now, however, if the north pole of one magnet is brought near the north pole of another magnet, the poles will repel each other. So just like with like charges, like poles repel. So we have here north would repel north, south would repel south. If you break a magnet in half, each half becomes a bar magnet. So if I were to break this magnet in half right here, this end would stay a north end, but right here at this end where it broke, this would become a new south. And likewise, this would stay south, but right here where it's broken, that would become a new north pole. Now, this will happen down to a single atom. So I could break this magnet in half and break it in half and break it in half until I am left with just one atom, or actually two, because then they would attract it or repel each other, okay? So right down to a single atom. So what this tells us is that atoms are magnets. So let's talk about magnetic fields. A magnetic field is a force field that fills the space around every magnet or current carrying wire. Another magnet or current carrying wire introduced into this region will experience a magnetic force. And so here you can see this magnetic field on this magnet in the background. What has been done is there have been iron filings um, placed around the magnet. And so these are the field lines where that force is. So we have field lines going from between the north and south poles here. Now, a magnet's strength is greatest close to the magnet, especially right here. You see at those poles, there's a lot of strength there. So, the nature of a magnetic field, where does it come from? A magnetic field is produced by moving charged particles. In the magnet, it's produced by spinning electrons. Now, remember from the definition of magnetic field, I said that a current carrying wire will also produce a magnetic field. That is because we have moving charged particles. There are moving electrons in wires, and so they actually create a magnetic field, and we will be investigating that in class. And finally, let's finish with magnetic domains. A magnetic domain is a microscopic cluster of atoms within with their magnetic fields aligned. So what this means is that in this magnet, the atoms are all aligned within the magnetic field. Um, if they're not, because iron, we can have a clump of iron and it cannot necessarily be a magnet yet, but if we place it in a strong magnetic field, its domains will become aligned and then it can become a magnet. Perhaps you've done this with a pin before. If you're a sewer, perhaps, or somebody in your family is a sewer, a lot of times, like at my house, my pins, I have a dish that has magnets on the bottom of it that I put my pins in. Now, my pins are not magnets. If I were to try to stick them to say, my metal refrigerator, my steel refrigerator, they will not stick there. They are not magnetic. But if I place them on the magnet, the domains in the pin become aligned, and then they do become a very weak magnet. I might even be able to attract something with them, especially other pins. And so we can create magnets by placing them in strong magnetic fields to align the domains. Now, this also means we have to be careful with magnets because if you drop a magnet, what you do is you jostle those domains out of place. They become no longer aligned, and you will actually weaken the magnet over time by dropping it and jostling those domains out of place. So, our objectives were to describe the differences and similarities between electric poles and magnetic charges, and to relate the motion of electrons within a material to the ability of the material to become a magnet. So, don't forget your 5 questions. And if you were listening to this video, go ahead and next to magnetic poles, draw a picture of the Earth with a magnet inside of it with north and south labeled. And I'll be back with, actually, this is a really short chapter, so I'll be back with one more video about magnetism where we really look at how it works with charges moving in wires more.